All right, one thing you guys need to know is that you'll always have your calculator. Always. I'm never going to take that away from you. So when I talk about calculating numbers in scientific notation, the extent of that is you need to be able to punch it into your calculator, like be functional with your calculator, because I'm not going to take it away from you. I promise. But I do want you to understand what it means for something to be in scientific notation, and it is not changing anything about the number at all. So it is just a shortcut for expressing a really big or a really small number. That's it. We don't want it to change anything about what the number means. We just want to write it easier. And we deal with really big and really small numbers all the time in this class. So to write them all the way out is sort of a big pain. So this is nice. What you see in your notes is something that looks like this. Oh, nice and straight there. Yeah? Oh, I didn't mean straight. I just meant that's in your notes, right? Okay. This first number right here is called the coefficient. And the coefficient of a number in scientific notation should always be a number between 1 and 10. This top number right here is the power of 10. Or your exponent. And this number might be positive, which would mean we're going to multiply the coefficient by 10 that many times. Your exponent might be negative. That's a negative. And that just means divide the coefficient by 10 that many times. That's it. So you might have learned this by like moving your decimal point left and right. Yes? Just like shuffling it over one way or the other. So if you're multiplying by 10, which way are you going to shuffle your decimal place over? Left or right? Yeah? If you're multiplying by 10, what should happen to your coefficient? Get bigger or smaller? Should get bigger, so you would go right. Yes. So that would be moving your decimal place to the right. And that would be of your coefficient. If you're going to divide, it's going to make it smaller, and you're going to shuffle your decimal to the left. I don't know, that confused me a lot when I was in high school. Sometimes it still does, the whole left-right thing. So if you can think of it just as like multiplying or dividing, you might be better off. So let's look at a couple numbers. I think you have number of carbons, atoms in the Hope diamond, right? Okay. That is 4.6 times 10 to the 23rd. Okay. So if I was going to write this out as a real number, and I'm just trying to demonstrate to you why scientific notation is wonderful, what would this number be? Large. Yes, it would be very big. It'd be 4, 6. How many zeros? 22. And this is one thing that I see happen a lot. So you're not just going to stick that many zeros on the end, because you might have some numbers here that take up some zero spots. So like timesing 4.6 by 10 once would give me 46. But then every other time I multiply by 10, it's going to give me a 0. So I'm going to have 46 with 22 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Isn't this fun? Okay, so why would anyone want to do that? I'm guessing they wouldn't really. So that's why we use scientific notation. Because we do have to do things like count atoms, and there's like these huge number of atoms. So we deal with these huge numbers. Yep, So your calculator will not accommodate that many zeros, so a number that's that big will automatically just be shown in scientific notation. If it's 4.6, I have to take up one of those times 10s, because I'm going to multiply by 10 23 times, right? Yes. Yes. Yep. Okay, and I think your next one is mass of a carbon atom. Is that right? Okay, so the mass of a carbon atom is 2 times 10 to the negative 23rd grams. So it's really, really small. One carbon atom has a mass of almost nothing. So if you were going to put this in scientific notation, we'd be dividing by 10 23 times. So right now, it would take me 1 time to get 0.2. So how many zeros would I have in front of this 2? 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 2. So yeah, we don't want to do that. That's why we need scientific notation. So take a look at your sheet. Your practice problems is what I'm referring to, sorry. And this would be what you're doing in part 2. And generally, I would say for you guys, part 2 tends to be a little easier than like part 1. Going from scientific notation to a normal or non-scientific notation number tends to be easier than the other way. So now we're going to do the other way. We're going to do some part 1 problems now. So we're going to do maybe 3 together out of the, what is that, like 16 that you have to do. And Kyle D gets to pick the first one. Pick me a number between 19 and 35. 27. Is that not what you said? Did you say 27? Okay. 27. 6,240. So now we're going the opposite way. We're taking this normal number, we're going to write it in scientific notation. Remember, we don't want to change what its value is, we just want to make it look different. So 6,240, write your coefficient first. If this was going to be a number between 1 and 10, what would it be? Good, 6.24, and we're going to put our times 10 to the. And now we need to know, what do I need to do to 6.24 to make it 6,240? Do I need to multiply by 10 or divide by 10? Multiply, right? So 6.24, and sometimes I would always do this in high school. Sometimes I would always. Sometimes I would put this little X here, and then I would just try to move it back to its original location. So I'm going to move it 3 times. I'm going to multiply by 10 3 times. So 6.24 has to be multiplied by 10 3 times to make it 6,240. Let's do another one. Eloise. Oh, she knew. She was just waiting to be called on. Oh, you turd. Is that 11 zeros? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 9, 1, 5. All right. So what would my coefficient be? 9.15. Now this time, to make 9.15, to make my coefficient back into the original number, do I have to multiply by 10 or divide by 10? Divide. 9.15 is way bigger than the original number. So I'm going to divide by 10, and I'm going to divide by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I count wrong?
No, it's 5.
Or did I miss a 0?
I
I had some trouble right here.
had 12. Yeah, it's 12.
Yep, it's 12. It's 12.
You said 14. I think it's 27.
There are 11 zeros. Okay, so there are 11 zeros, but it's times 10 to the negative 12th because it takes us 1 dividing by 10 just to get past this 9. All right. Drew, you're up. 33. Oh, good golly. 26. Okay, we're going to change 26 to 3s to that. Change your last 0 to a 1. Because I said. I know. Take that. I just want to show you something. That's all. If we didn't change this, if this was just 80, what is that? 80 billion? You could just write your coefficient as 8. 8 times 10 to the. Can you write it as just 8 now? No. So now you have to write all these zeros and the 1. So our coefficient is now 8.0, 0, 0, 0, 0, 0, 0, 0, 0, 1 times 10 to the. Okay, so you can't just drop numbers at the end of these. I'm just trying to show you something. Maybe. Okay, so how many times, wait, do I have to multiply or divide my coefficient to get back to the original number? Yeah, 8 is a lot smaller than 80 billion. So I think this should be a 10, am I right? 5, 6, 7, 8, 9, yep. Talk to me. I'm very confused by. You good? Anybody else confused? So I want you to try the remaining problems from 19 to 35 in part 1. All of part 2, flip over onto the back part 3.